Okay, so now they want you to find out how many times does x equals 5. So x equals 5 intersects the graph how many times? So x equals 5. What is x equals 5? Well, it's a line, huh? It's a straight line that goes through the x-axis at 5. Here's the x-axis at 5. Where's 5? Well, this is 2, 4, 6, 8, 10. You know, it goes by 2s. So where's 5? Right here between 4 and 6?
Uh-huh.
There it is. There's the line x equals 5. Right? The line that goes through the x-axis at 5. How many times did that hit the graph? Well, just once. It's right there. One time. Good? That's all they want. How many times does it hit the graph? Hits it one time. Nothing more than that. Last question. Oh, wait. What is the last question? I can't tell. Let's come over here. F of x equals 6. What is x? So let me let you try that one. F of x equals 6. What is x? So the key to reading this is knowing what's in here is x, what's out here is y. So they're saying, find y6. Go to that blue graph and find the point that has a y value of 6. It's right here. That's not the only one, though, huh?
Yeah.
And it's right here. This also has a y value. So what x values go with that? 0 and 8. They want both answers. 0, because just put a comma between them. 0, 8. They're both x values that have a y value of 6, aren't they? Is that good? Last question. What's the domain of f of x? What does domain mean? Is the domain question? I know it's. I was working with some students yesterday in my office. I could tell it's confusing. I'm trying to make it more clear. Domain. There's two ways we do domain, and that can be confusing. We do domain for pictures, and we do domain for equations. And we do different things, right? So for a picture, it's the width coverage. You just look at the graph and say left edge, right edge. It's actually easier for the pictures, huh? So domain is width coverage because it's x values, right? So you just say how far, the domain, let me just draw it right here. The domain is how far right, how far left does this graph go? What's the width coverage of the graph? That's what you do when you have a picture for domain. So it's just left edge, comma right edge, brackets or parentheses, depending on whether it hits those edges straight on or just gets close. So what's the left edge? Well, right here. X value negative 12. What's the right edge? Right here. X value 22. It hits those straight on, right? Solid dots on both ends. So it's going to be bracket, negative 12, 22. There we go. Brackets. Well, I don't know if you can read that. Let me move it over. So, because of the watermark there. Negative 12, 22. That's the answer. Left edge, right edge, right? It's always left edge, right edge.
So on pictures like this, there's always going to be brackets. It's not ever going to be...
No. A good question. If they had made these open dots on the ends here, if they'd made that an open dot, then I would have to do parentheses because it wouldn't actually hit it right on.
On the edge of the actual line?
What's that?
On the edge of the actual line that was written on the graph?
Yeah, they could. Yeah, right. Yeah, you're right. They would go like this, and they would end with an open dot. Yeah, you're right. Exactly. If they made this an open dot instead of closed. So open dots mean parentheses, right? Because you don't hit it right on. Solid dots mean brackets. You're straight on that number. What if they put arrows? Then that's negative infinity. Then it's going forever left and right. Negative infinity, positive infinity, right? We good with all that? Mm-hmm. All right. So there we go. So the first thing they're asking about that one is they say, hey, is it a function? You can see my answer is no. Why is that not a function?
Because the vertical line test.
Because vertical line hits 2 points. Remember the vertical line test? Vertical line test is if any vertical line hits 2 points, it's not a function. So this one's no, and we're done. You don't even have to answer the rest of the questions when it's not a function. You're hoping it's not a function. and you're out of the rest of the work. So that one's not a function because a vertical line hits 2 points. Remember, because that means there's one x value going with two different heights, huh? Right? Remember, that's the fundamental issue with a function. One x can only go to one y, not two. That's what the vertical line shows, right? This might be, I don't know what this is, but maybe this is over 3, down 4, and this is over 3, up 4. I can't tell exactly what it is, but it's something like that, right? They're both over the same amount, up different amounts. That's two y values going with only one x value. One x goes to two different y's. That's not allowed. That's not a function. That's what the vertical line test tests. Okay, so first off, let's do domain and range.
Okay.
So go ahead and do the domain on that one. Got a picture.
That's 3.
So domain is the width coverage, right? So domain on a picture is left edge, comma right edge, with parentheses or brackets or whatever the edges should have. So left edge, right edge. So on a domain, it's left edge, right edge. So what's the left edge?
Negative pi.
Negative pi, and the right edge is regular pi. And those are brackets because those are solid dots on the end. Straight on it hits those. Is that good on that? And then what's the range? Remember how range, same thing, but instead of left, right, it's bottom, top. It's the vertical. I can write it like that. So range is, how low, how high? Range is bottom, top. So range is the vertical span. Domain is the sideways, horizontal span, right? On a picture. So what's the vertical span? What's the bottom? -1. Top is regular 1. Again, brackets, because it's solid. It hits those all the way up, all the way down. I mean, there's a solid graph there. Good on that, domain and range. And then they're also going to ask symmetry. Is that what they ask? What are the intercepts? Let's do that. What are the intercepts? So it would be here, here, and here. Right? Intercepts are places where the graph hits the grid lines. So what's the coordinates of this point? Back pi up 0. This one's 0, 0. And this is over pi up 0. So back pi up 0, over 0, 0, over pi up 0. Those are 3 different points separated by commas. Are you with me? Is that making sense? And lastly, they talk about symmetry. What do they mean about symmetry? Okay, so let me just give you some examples of graphs with symmetry. If you have a U-shaped graph, here's the y-axis. That is y-axis symmetry, because it's the same on the two sides of the y-axis. Now, that's not what we have here. I'm just going to show you the 3 different kinds of symmetry. So there's that kind. What if you have a graph that goes like this? Well, that graph, this is the x-axis, that would be x-axis symmetry, because it's the same on the two sides of the x-axis. The x-axis is like a mirror for it, right? It's reflected across the x-axis. The x-axis is acting like a mirror. On this one, the y-axis is acting like a mirror, so it would have y-axis symmetry. Same on both sides of the y-axis. The third kind is, I'm out of room for it, origin symmetry. And that's the trickiest kind. Origin symmetry means if you flip it 180 degrees, it's back on itself. So it's a half flip, 180 degree rotation. Flip, or yeah, let me just write it that way. Flip, that's right. Flip 180 degrees. It's back onto itself. In other words, 2 quadrants away, it's the same, because that's 180 degrees, right? 2 quadrants away. That's what this one has. This one's got origin symmetry. Do you see it? If I was to take, let me just draw it here. I to take, well, maybe, I think I did already. Yeah, there it is. Yeah, here it is. I've got it. Big side is on the left. So, see it. This says on the, is this right? I don't know, whatever. I might have it up there. Is it this one? Yeah, oh, there it is. Yeah, left is it. Yeah, this is it. Yeah, so there's the graph. If I take that graph, you ready? And I turn it halfway around, nothing changed. Looks just like it did a minute ago, right? Same thing? Same thing. 180-degree rotation symmetry, right? So that's what this graph has. If you take this piece and go 2 quadrants away, 1, 2, it's back there, isn't it? It's back unto itself. 180-degree rotation. So this one has origin symmetry. Why we call it origin? It doesn't have x-axis or y-axis, it has origin. Why we call it origin, you might wonder, like, what's the origin have to do with it? It's because if you take any point on the graph, like let me just grab this point, and you go through the origin, same distance other side, you'll find the same point. It's all reflected through the origin. Take this, any point you want, take that point. Go through the origin, same distance other side, boom. Take any point, go through the origin, same distance other side, boom, etc. All the points are reflected through the origin to the same distance on the other side. The origin's like a little tiny mirror. But it's easier to just think, what if I flipped it halfway around? That's origin symmetry. All right. Questions, comments, feel free to speak up. I'm going to move fast. Okay. So, first question, is that one a function?
Yes.
Yeah. Every vertical line would only hit 1 point, huh? 1 point, 1 point, 1 point. Every perfectly vertical line would only hit 1 point. So that's a function. So, yes, it's a function. So now we got to answer all the questions, don't we? So, okay, first question, what's the domain? Let me let you try that. So you remember domain, left edge, right edge, brackets, parentheses, whatever's appropriate on the edges. Try that one. So you go up here. So it's like you're a little person walking on the x-axis, going back and forth on the x-axis. Where do you see graph? Right? That's what we're talking about with domain. So the domain, how far left, how far right do we see graph? Well, how far? Well, this graph goes down and left forever. That's what that arrow means, right? So that's left edge, negative infinity, always a parenthesis next to infinities of any kind, because you can never be right on infinity. Right? Okay. What about the right edge? How far right does it go?
0 but doesn't touch.
0 but doesn't touch, 0 parenthesis. Everybody see that? It goes from negative infinity to 0. That's the domain. Left edge, negative infinity, right edge, 0. Right? This graph gets closer and closer to the middle forever without ever touching it. Good? How about the range? Range is bottom comma top. Parentheses or brackets or whatever fits correctly with the edges. So what's the bottom?
Infinity.
Goes down forever and up forever. So this is negative infinity, positive infinity for the range. Is that good? We good there? Intercepts. What are the intercepts on this one? Where does it hit the grid lines? Just right there, huh? That's the only one. What is that point? That's a back 1 up 0, looks like. Finally, does it have any symmetry? No, none of any kind. Do you see that? It's not the same on the two sides of the y-axis. It's not the same on the two sides of the x-axis. It doesn't have origin symmetry. If you rotated it halfway around, it would look different. It wouldn't go back unto itself. It's not the same 2 quadrants away. Is that okay? No symmetry of any kind. Everybody okay with that? Questions? Maybe this one has a little bit of interest to it. So try that one. Start with the domain. It's left edge, right edge. All right, left edge, right edge. So left, right, with parentheses or brackets. So what's the left edge, right edge?
Infinity, infinity.
Negative infinity, positive infinity, right? Good. What's the range now? The range is a little more tricky. Try the range. Bottom, whoops, bottom, comma, top. So the range is this way, right? So yeah, so what's the bottom? Well, the graph, this goes down forever. So the bottom is negative infinity, parenthesis next to infinity is always. What's the top? Yeah, this height is 4. See the y value? We're looking at y values, not x, right? And it's a bracket because it's right on the 4, huh? Everybody see that on the range? The top is 4. A common mistake I see in the exam, people grab the x. That 2 means it's over 2, up 4. We want the up. Range is all about y values, right? It's up 4. Is that good? Intercepts, yeah, it's got a couple intercepts, whatever. Can you tell what? Yeah, so it hits here, here, and here. What are those intercepts? I can't tell. Can you tell? What is it? It says this is 8. Okay, so I don't know if you probably can't see that way back there. This is, oh, this is 2. That's right. You can tell this is 2. So this must be 2. Oops. Yeah, 2, 4, 6, 8. 2, 4, 6, 8. So it hits at 6, looks like, huh? And back 6, and this is up at 4. So it'd be back 6 up 0, over 6 up 0, and over 0 up 4. Any order. You can put those in any order, just with commas between them. Is that okay? And finally, any symmetry. Does that one have any symmetry?
Yes, it does.
See how it's the same on both sides of the y-axis? It's the same left and right of the y-axis. It's got y-axis symmetry. Is that good? Questions on that one? All right. If you're okay with that, I'm a... No, not graph it. Just a bunch of questions about the graph without ever seeing the graph. So they're giving me that function. F of x equals 4x squared minus x minus 3. Yeah, so now they're kind of shifting gears. There's no picture. They're not going to have me get a picture at all. We're never going to see the picture. But they're going to ask me a bunch of questions about the picture. It's kind of like learning to fly a plane blind by the instruments, right? We're not looking out the window. We can't see the picture, but we have to learn the instruments better. So what do the instruments tell us? First question is, so question A, is negative 1, 2 on the graph of f of x? Without ever seeing the graph, just by looking at the instruments, how do you know whether negative 1, 2 is on the graph?
None.
What do we do? You know, right? We just plug them in, don't we? Just plug them in. So that's what we do. We just plug them in. So this is x, this is y. So x goes there and there. Where does y go?
X goes to the f of x.
Yeah, the f of x, the whole thing is y. Remember, that's by common agreement in math science world. They just said function values, any function, f of x, g of x, h of x, whatever, that's y. Those are y values when it comes to a graph. It was just decided that way. So 2 does 2 equal 4 times negative 1 squared minus negative 1 minus 3? That's the question. I don't know. What's this? 4 plus 1 minus 3? 5 minus 3? Yeah, it does, huh?
Yep.
Kind of scribbled that. 2 equals 2? Yeah, it's true. We good? So that's part A. Let's go on to part B. Part B up here says, if x equals 2, what is it? So x equals 2, what is f of x? Well, that's just plug. I'm going to skip that. I don't got time to do all the easy stuff. C would be very good to do, though. Let's definitely do C. I'm going to go to C. They're saying f of x equals negative 3. What is x? F of x equals negative 3. Try that one. So that means you take all of f of x and you set it equal to negative 3, right? All of f of x equals negative 3. Good so far? Okay, now what's the game plan when we have an x squared? We've had this a couple times now. What do you do when you have x squared with equal sign? Step 1,
To 0.
look over at your neighbors. No, okay. Get a 0, right? Get a 0, right? So you want to be really crystal clear. It's going to come up a lot. So when you got x squared, first step, get a 0, then you try the factoring thing, right? Remember that? Try to factor. I say try because they don't always factor. So first step when you've got x squared is you've got to get a 0. So I add 3 to both sides y to make that right side 0. Good so far? So always do that first. Get a 0. Want to be real clear. Put that in your 3x5 card for the test if you need to. Be real clear on that. And now factor. This is just take out a GCF, huh? This is just take out x for factoring. It's not 3 terms, so I'm not doing the 2 parentheses. When I write 2 parentheses, I just mean usually we factor that way, but not always. Right? Usually there's 3 terms when we do the 2 parentheses thing. But here we just have 2 terms. It's just take out the GCF. Take out what's in common. Good. And what do we do from there? 2 things are timesing. If you times 2 things to equal 0, either one could be 0 to make that true. The first one's 0, 0 times anything can be 0. The second one's 0, anything times 0 is 0, right? So the first one can be 0, or the second one can be 0. So jump the 1 over there, becomes a positive 1 divided by 4. So the answers are 1/4 and 0. Is that good? X is 0, x is 1/4. Questions on that? Actually, you know what? They ask a little more than that on this particular question. Let me help with the second part. So they also say, what points does that mean? Do you see it? Do you see what? Can you read that small print here? What points? So yeah, okay. What is x? What is x? We got it. And so we've got, so on part C, we've got x is 0 and x is positive 1/4. We've got the x's. What is x? We got that. But then they're saying what points? Well, what do you mean what points? Meaning they want you to plug in x and get the y. In other words, they want 0, comma what? 1/4, comma what? They want the y values. They want the actual x, y points. Does that make sense? So we got to find the y value. This is the x. They want the y value with it. This is the x. They want the other y value with it. How do we get that? Plug it into the equation, right? Because it's y. Let me come down here. So it's y equals, because f of x is y. So this is y equals 4x squared minus x minus 3. So the 0 is easy. Plug in the 0, right? When you plug in 0, you get, you can tell it's just going to be negative 3, huh? Negative 3. So that's 0 minus 3. And then, secondly, start again. Oh, I'm just running out of room here. Need a little more room. So, secondly, plug in x is 1/4. Well, that's going to be a little ugly. Plugging in x is 1/4. You know what I would do? Use my calculator and plug in 0.25 instead. Just use a decimal, plug in 0.25 with your calculator. Be a lot easier than messing around with fractions, you know? Right, because 1 divided by 4, right, a fourth of a dollar, 25 cents. So just plug in 0.25, hit the buttons on your calculator. So 4 times 0.25 squared minus 0.25 minus 3. Kind of running out of room again. Minus 3, hit the buttons. What is that? Maybe 16 1/4. Oh, it's going to be negative 3, isn't it? You guys do it on the calculator? Negative 3. So, what does that mean? Oh, so they're both negative 3. Oh, that was dumb of me? Hello? Is anybody seeing how dumb that was? Why was that dumb? That was dumb. Because they already told me y was negative 3. Why did I do all that work? Don't do that. That was so dumb. Right? They told me. That's the whole thing we started with. They said f of x, which is y, is negative 3. So find the x's. We found the x's, and I said, yeah, I wonder what y goes with those. Well, that was dumb. We already knew. We started by saying y is negative 3. Of course y came out negative 3 for both. Yeah, don't do that. Sorry, that was dumb. All right, good. Yeah, so don't do all that work. We don't need to do all that. That was dumb. Of course y was negative 3. All right, D. What's the domain? Yeah, let's do that, though. This, I know, confuses people a lot. Let me erase this side if I can. So, what is the domain of it? Now, this I know has been confused. I want to try to say this more close. I love it when people come to office hours and I can hear what's coming across and what's not coming across, and it helps me to teach it better the next day. So, what's the domain of f? Here's the function f of x equals 4x squared minus x minus 3. So, no picture, right? Just an equation. How do you find the domain when they just give me an equation and they don't give me a picture? Are you comfortable with that? I think I haven't made that as clear as I could. Let me make that more clear. So if we had a picture, we just did a bunch of those. Left edge, right edge, no big deal. But if there's no picture, how do you do it? Well, let me say it better. You do this. In fact, I want more room, I just realized. So the domain. How do you do domain? Check two things. That's what the 1 and 2 is. Number 1, check if it has a denominator, then denominator not equal to 0 and solve. Number 2, if instead it has square root of something, take the inside out and set greater than or equal to 0 and solve. 3, if it has neither, then it's negative infinity to positive infinity, because anything goes. Can you read that? That has neither, this says. I should get rid of that watermark. I gotta buy the program. It's like $30. I'm just too cheap to do it, and there'd be no watermark. All right. So domain. So when I wrote the domain steps before, I think I made people think you've got to do step 1 and then you've got to do step 2. And no. It's either 1 or 2 or 3. It's just one of those, right? If it has a denominator, well, then you do that. If instead it has a square root, you take the inside greater than or equal to 0 and you do that. If it has neither, it's just negative infinity to positive infinity. That's how we do domain when we don't have a picture. So what's the story with this one? Where's our function? Right here. So check number 1. It's like you're checking your car for the oil and everything. So does it have a denominator? No. All right? The oil's fine. Go on to the tires. Does it have a square root? No. Well, then you're good. Right? You see the idea? So there's no problem areas. You can put in any x you want. Negative infinity to positive infinity would be the domain for that one. So that's what we're doing with domain. We're trying to limit it. We're saying what can you not? What are you not permitted to plug into this thing? Well, denominators. Anything that would make a denominator 0 is not allowed. Anything that would be negative in a root is not allowed. So anything goes. List the x-intercepts, y-intercepts. Maybe we better do that. Y'all got that down. I'm going to do this last part, which I think is valuable. So E says x-intercepts. How do we find out? We did them on a graph a minute ago with a picture. But how do we do x-intercepts from an equation? What do we do? Y equals 0. Is everybody good with that? Right? Think about it for a minute. If you have a graph and it has an x-intercept point, that means it's over, I don't know, whatever, say 3, up 0. I don't really know how far it's over, but it's up 0. Right? If you're an x-intercept, your y value is 0. That's what it means to be an x-intercept. Right? If you're on a graph and you're an x, if you're hitting the x-axis, you're at a height of 0. So that means intercepts, you always set the other letter to 0. At an x-intercept, y equals 0. Up here, look at this. Here's a y-intercept. What do you know about that? It's over 0 up something. I don't know how far up. But it's over 0. The x value is 0 at a y-intercept. Right? Are you clear on that? Whenever you find intercepts, you set the opposite letter to 0. Because that's automatically what they mean. A y-intercept has x0. An x-intercept has the y0. Doesn't it? So they want x-intercepts. I just make y0. Where's y? Right here. This is y. Make that 0. So let's do that. Make that 0. All right, and then I need to solve that. How do you solve that? You're either a good factorer, and you do that, or you do the quad. I'm going to do the quad. So negative b plus or minus. The quad's for solving any x squared equation. Square root of b squared minus 4ac all over 2a. This is a. B is negative 1, c is negative 3. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And so what do we get there? 1 plus or minus the square root of 1. This is negative times positive times negative. 2 negatives. Positive was that 48 all over 8. 1 plus or minus root 49 over 8. That's 1 plus or minus 7 over 8, right? Square root of 49, 7. So what are those two answers? 1 plus 7 over 8 and 1 minus 7 over 8. What is that? 8/8 and negative 6/8, which reduces to be negative 4/3. Oh, 8/8 is 1, of course. So negative 4/3 and positive 1. 3/4. What did I do there? Saw you guys all giving weird looks. When everybody's giving weird looks at once, that means I did something weird. Is that better? Is that good? Right, I just did the 1 plus 7 and the 1 minus 7 over 8. Which is 8/8, 1. Negative 6/8, reduce it by top bottom by 2. We good? So those, yeah, so you just do the quad. You can factor. If you're a good factorer, you could just factor this thing instead. Whichever you prefer. How about the y-intercepts? That'll be easy. What do you do for y-intercepts? X to 0. So you take this equation, put in 0 there, put in 0 there. What is y going to equal? Negative 3, we're done. That one's super easy, right? Just plug in 0 for x. They just drop out y. F is just negative 3. Good on that. 2. Okay, so for this one, 14x squared over x to the 4th plus 49. They want us to do domain. I mean, all the other stuff is pretty easy. But how do you do domain? Let me do that with you. Domain, now remember, for domain, for an equation, we look for trouble spots, right? It's like checking your car. How are the tires? How's the oil? So what are we supposed to check? That one has something that might be a problem. What is it? Got a denominator, right? It's got a denominator. That can be, in some cases, a problem. Right? We say, all right, it's got something to look at. It's got a denominator. And we say, denominator, you cannot be 0. Because that's a problem, right? Dividing by 0 just messes it up. So the bottom can't be 0. All right. Can you solve that real quick? Go ahead and solve that. what to do there. If I bump this to the other side, get x to the fourth is, or not equal to, minus 49. Now, what could I do now? You could fourth root it if you want. What's going to happen with a negative and a root?
Imaginary.
It's imaginary. Meaning there's no real problems. All your problems are imaginary. All the problems of this function are imaginary. There's no real problems, so the domain is anything goes. Did you track with that? Right? You could probably look up at this for a minute. We didn't need to solve. There's no way he's going to equal 0. Anything you plug in here to the fourth power is going to be positive, right? Or 0 at the lowest. Not going to be negative. Then you're going to add 49. It's not going to be 0. There's no way to make that 0. There's nothing here. Forget that, right? I mean, that's what we found here. That's why it's imaginary. There's no real way to make that 0. Does that make sense? So there's no real way this denominator will ever be 0. Therefore, there's no problem, right? It's like a microwave oven that can take tinfoil and everything. I don't know, some super microwave. Throw anything in there. It's fine. It doesn't matter. Anything goes. Nothing will choke the denominator. All real numbers are fine. All right, good? In the hang of domain? I wouldn't draw that whole graph. It's, but we want f plus g of 4. So give that a try. It's graph reading. Last one on this section, I think, or second to last, huh? All right, so what do we do? Do you know what they're talking about? This means f of 4 plus g of 4. I did not just multiply there, by the way. Remember, none of this means multiply. This just means the function, both the functions at 4 added. So I just wrote it that way. It's the same thing. So what is f of 4 from the graph? Which one's, did they tell me which one's f? Oh yeah, the red one. See how the red one's f? It says right here, small little f there. The red one's f, the blue one must be g. Oh yeah, there it is. The blue one's g. See how they said it right here? So the red one's f. So what is f of 4? That means x value 4, answer will be whatever y is. So when x is 4 on the red graph, right here, what's the y value that goes with it? 5. So this is 5 plus, we good so far?
0.
Then when the x value is 4 on the g graph, x value is 4, what's the y value? 0. 5 plus 0 is 5. You see how I read those off the graph? So again, remember, with function notation and graphs, what's inside is x, the answer that comes out is y. So on the red graph, on the f graph, find the x value 4, grab the y value. On the blue graph, the g graph, find the x value 4, grab the y value that goes with it, 0. Is that good? And then they ask you a bunch of other questions just like that. Just reading the graph.